Hi guys, my name is Dr. Huey and I'm a psychology professor at New York Institute of Technology. And today I am going to walk you through a independent samples t-test example. So an independent samples t-test looks at two different groups of participants and compares their means to see whether or not they're statistically significantly different, basically. So I'm going to walk you through an example, and that's honestly the best way to kind of get the formulas and understand the steps. I will tell you that the steps can seem overwhelming, but the math is all pretty basic, and once you learn the steps, everything's pretty easy to do. It's just a matter of like following directions with these examples. So we have an example of a t-test for independent means here. 20 students were recruited to take part in a study that investigated whether expressive writing was associated with overall physical health. So we have two different groups. One group of participants was randomly assigned to the expressive writing group, and another group was the control group. So they were just supposed to write about their plans for the day. Nothing that helps to facilitate, creativity and thought and things like that, just something very basic. 1 month later, the students were rated on their overall physical health from 0, where they had very poor health, to 100, which is perfect health. So first thing that we're going to do is we're going to look at the data. So the first thing we're going to do is we're going to restate the research and null hypothesis so we know what we're looking for. Then we're going to look at the data. So the null hypothesis is essentially that there's going to be no change in health between students who participate in their expressive writing versus students who write on a neutral topic. And then the research hypothesis is going to be that there will be a change. So we're not really, in this example, it's going to be two-tailed because we're not going to say any specific directionality. So two-tailed means it could either increase or decrease. It could go in either direction. But we're going to say that there is a change between students who participate in expressive writing and students who write on a neutral topic. So now we're going to present the data for the study. So 10 participants were in each group. On the left, we see the expressive writing group, the 10 participants, and the scores that they had for each, for their physical health after they received their expressive writing condition. And then for the neutral writing group, we have all the participants and then the scores that they received for that group. So the first thing that you're going to do is you're going to find the sum of squares for the first group. So to the left here, we have our expressive writing group. We have our number of participants, 1 through 10. We have each of their scores, and then we added all of those up and divided by 10 to find the mean of 79. And then your second step to find the sum of squares is you're going to find the deviation from the mean score. So each score minus the mean. So for example, for participant 1, they scored a 77 minus the mean 79 gives them a -2. For participant 2, they scored an 88 minus the mean, which is 79, they scored 9. So you do that for each participant in your study. And then you get the squared deviation from the mean. So what you do is you simply square the deviation from the mean score. So for participant 1, again, their score was 77, the mean was 79, so they ended up with a deviation from the mean score of -2, and then you square it. So -2 squared is 4. For participant 2, the score was 88. You subtracted the mean, 79, 88 minus 79 equals 9, and then you square it, 81. And then you do that for each score in the data set. Once you get all the squared deviations from the mean, you add up those numbers, and that is your sum of squares. So the sum of squares for the expressive writing group is 850. You're going to do the exact same thing for the neutral writing group. So you have all the participants and all their scores. Once you add up the scores, you divide by 10, and you get a mean of 68. For the first participant, they scored 87. So you do 87 minus 68, and you get 19. And then you square that, and you get 361. For the second participant, they scored 77. And then you have a mean of 68. So you do 77 minus 68, and you get 9. And then you square that, and you get 81. You do the same thing for all the participants in the data set for the neutral writing group. And when you add up all the squared deviations from the mean, you get 1002. So those are the first two steps that are pretty straightforward. You're just finding the sum of squares for each group. Then what you want to do is you want to find the degrees of freedom for each group. So degrees of freedom is n, which is your total sample size, minus 1. So our sample size in this case is 10. So we're going to do 10 minus 1 is 9. And that's the same for both groups. We have the same number of participants. obviously, if you had different numbers of participants for each group, which may very well happen in real data collection, the numbers of the degrees of freedom might vary, and that can change your, what you're doing here. So the degrees of freedom for each group is 9, and then the degrees of freedom total, which we're going to need later, is 18. So the step 4, it's 10 easy steps, guys. It's just kind of walking through each of them, is you're going to calculate the estimated pooled variances for each sample. So the pooled variances is simply the sum of squares divided by the degrees of freedom. So the sum of squares for the first group was 850. The degrees of freedom was 9. You do 850 divided by 9, and your pooled variance for sample 1 is 94.44. For the second group, the sum of squares was 1,002 divided by 9, and your pooled variance was 111.33. So your estimated pool variances for each sample are in bold below, 94.44 for the first one and 111.33 for the second. Then what you're going to do is you're going to find the pooled estimate of the population variance. So what you're doing is you're finding basically an estimate of the two different populations variances, and you're going to use that to calculate your t-statistic. So the formula's up here. What it basically is your degrees of freedom for the first sample over the degrees of freedom total times that statistic that we just calculated, the estimate of the population variance for each sample. And then you do that for the second sample as well. Degrees of freedom over the degrees of freedom total multiplied by that statistic that we just calculated before, which was the estimate of the population variance for the second sample. So you do 9, which is the degrees of freedom for the first sample, divided by 18, and then you multiply it by 94.44, and then you add 9 divided by 18 multiplied by 113.33, and you get 102.89. So our pooled estimate of the population variance is 102.89. We're going to need this number shortly for our step 5. So our step 5, what we're going to do is we're going to find the variance of each distribution of the means. So what you do is you take the pooled variance that we just calculated and you divide it by n. So in this case, since our samples have the same number of people, the number is going to be exactly the same because our pooled variance is the same for both samples. It's the variance pooled for the two groups. And then you divide it by the sample size. So we do 102.89 divided by 10, that's 10.29, and 102.89 again divided by 10 is 10.29. So again, if the ends were different between groups, these numbers would be different. But if the ends are the same, you'll know this number, the variance for each distribution of means is always going to be the same. And then you're going to find the variance of the distribution of difference of the means. And what you're going to do is just add those two numbers together. So the difference of means here is 20.58. Step 7, you're going to find the standard deviation of that number. So all you do to find the standard deviation of a number when you have the variance is you take the square root. So you're going to take the square root of the distribution of the differences between means. And in that case, that's 20.58. And the square root of that is 4.54. So now you are ready to calculate your t-statistic. Your t-statistic is simply the mean of the first group minus the mean of the second group divided by that standard deviation difference of the distribution of means that you just calculated, that 4.54. I know it's a mouthful. So you do 79, which if you remember was the mean of the first group, minus 68, the mean of the second group, divided by 4.54, the number you just calculated, and your t-statistic is 2.42. So now what we need to do is determine the shape of the distribution and the cutoff points. So we're going to be looking at the total degrees of freedom in this example, which is 18, and we didn't talk about a specific direction, as I mentioned before, so we're going to be looking for a two-tailed test. And when you go to your t-table, you're going to look for 18, and you're going to look for the significance level of 0.05, 5% significance level, which in this case is plus or minus 2.101. So we need to decide now whether or not 2.101, whether or not our t-statistic falls outside of the boundaries of 2.101. So what I mean by that is, in the positive way, is it greater than 2.101? And on the negative side, is it lower than negative 2.101? So in our case, 2.42 is greater than 2.101, so it falls outside of the boundaries of what we consider a normal distribution. And what we can do is reject the null hypothesis. And based on the means, if you remember from what we calculated in the beginning, the mean for expressive writing was higher than the mean for the neutral topic. And so based on our means and the fact that we can reject the null hypothesis because our t statistic falls outside of the boundaries, we can say that students who engage in expressive writing report higher physical health than students who write about a neutral topic. So based on this example, I would say that you guys should all try to write expressively as much as possible. And hopefully this helps to walk you through what an independent samples t-test looks like. Thank you guys. And of course, you're welcome to contact me with any questions or additional information that you may need.